Hi, I'm Asif Azad, and this is my project partner, Fahim Muntasir, and we have done this project called Design and Penetration Control of PV and Wind Energy Systems to supply low-cost continuous power to a remote community in India. And this project was done by the supervisor, Dr. Ashraf Ali Khan. Well, in this outline, we're gonna discuss about the problem statement, solution, introduction of a hybrid energy system, energy methodology, community selection, project modeling, resources, case study, controlling method, financial analysis, and conclusion. It's like a problem statement. It is essential to conduct a feasibility study for any kind of project and other stuff to look it's feasible or not. And we chose India and it's India for the project, and as you can see from this picture that Uttar Pradesh and Bihar is the lowest household electrification level. It's just 39%, and we are trying to put two kind of renewable sources here. For the one is wind energy and one is PV sources, solar panels. As India has got both rainy seasons and summer seasons. So if in the rainy season, let's say in the rainy season, solar panel cannot get that kind of power, that they cannot generate that kind of power because there will be cloudy, no suns. So in that case, the power generation will be less than the demand. So to cover up this side, we also installing an wind energy to cover up the power, to cover up the demanding power. Like say in the cloudy weather, like in the rainy season, there will be lots of wind. So wind turbine can cover up the demanded energy in that season. But in the sunny season, sunny weather, the solar can do his part to cover up the demanded energy. And before that, people are using like generators and other stuff, but they are really expensive for the fuels, because government is not providing them in other solutions. Well, this is an hybrid renewable energy, so we used a PV model, a generator, wind turbine, battery bank for the storage for both of them, regulation and conversion. And as the solar only supplies the DC current, that's why we need an inverter to convert the AC to DC. But the wind, it's giving the AC, so we can connect that one directly to our load. And we are using this hybrid solar system to reduce the fossil fuels and the emission of carbons and other stuffs. And this is also very cost effective to use the hybrid renewable energy system. Hi, in this project methodology, we are like selecting an appropriate site with available potential resources to implement a hybrid arrangement for the site. Actually, the design and overall system incorporating solar and wind turbines are done in Homer Pro software, and the penetration for renewable will be calculated based on the generation, consumption, and the percentage, and it was done on MATLAB. The controller design and the simulation for the proposed system will be done in also MATLAB simulating to demonstrate the system output power bearing the site condition. And the result will be the comparing with the off-grid and the on-grid system, like which one is more essential and more feasible, like cost effective. And we can see, as you can see from the graphs, that we are going to set up a hybrid renewable system in Jharkhand, India, and it's very essential to analyze the site resources of the location. So this site got average 4.27 meter per second wind speed in Jharkhand, and yearly solar radiation is like 4.13 kilowatt per meter square per day. Now, the data is suitable enough to establish the hybrid energy system in the community. As India is the equator region, the solar radiation is high to operate a PV system efficiently. Therefore, to maximize the output for the system, we'll keep the penetration high in the solar system. Well, in project modeling and resources, like as you can see from that here, and we took a help from a research paper because we didn't have any live load data from the for this area and the household work. That's why we used a paper from Google Scholar. And in here we used a wind turbine and one PV model, two residents, like one has the 5.28 kilowatt hour per day consumption and 1.12 kilowatt peak. So you are also using a battery storage to store the storage, and will be using an inverter, as PV doesn't give the power in AC mode. They have to convert the AC to DC. That's why you're using an inverter. The it is a wind turbine specification that we will be using. That we use the turbine from the company, reputed company called Lotus Engineering Technology Corporation Limited, and the rated capacity is 1 kilowatt, and the type is vertically vertical axis wind turbine, and the height is 1.90 meter, and the lifetime is like 20 years. The solar panel specification will be rated capacity 1 kilowatt, and it will be flat type, and the lifetime it got 25 years, and it's also from a reputed company. It's a genetic flat plate PV. And this is the inverter specification that we used for our solar panels, and it's from the Strutter Innotech, and battery nominal voltage is 12 volt, capacity is 1 or 2.1 kilowatt, and output voltage is like 230. Our output frequency is 15 hertz, and the operating temperature is minus 20 to 50 degrees Celsius range.
So after the simulation in Homer Pro software, we so now we need to design a controlling system, because to get the maximum efficiency and maximum output from both systems, we need to design an appropriate control system. So first of all, we will discuss about the controlling arrangement of the PV system. So the Homer Pro software gives the penetration of PV cell is approximately 60%. To be accurate, it is 57.8%. So to ensure the most cost efficient output from this PV cell, we need to extract the maximum output from the solar panel regardless of the external factor, because the voltage and the output temperature or the ambient temperature might deviate the output of PV cell. So regardless of these circumstances, we need to ensure the PV cell can produce maximum output. So in order to do this, we will use an MPPT charge controller so that the PV cell can deliver the maximum possible output to the load appliances through the battery storage system. So this is the proposed PV system arrangement. As you can see that we will use a DC to DC boost converter, and we will use an MPP charge controller. So this MPP charge controller will be integrated with an algorithm. So this algorithm will take the feedback of voltage and current. So based on its feedback, it will feed the voltage to the DC to DC boost converter, so that the DC to DC boost converter provides maximum output to the battery storage system, so that the PV system can maintain its maximum efficiency. So this is the circuit diagram of the boost converter. So as you can see that there is a PV cell and there is an MPV charge controller. So it will get the feedback from the PV cell, and based on that feedback, the MPV charge controller will control this duty cycle, and duty cycle will control this MOSFET. I mean, as per the requirement, it will turn off or turn on this MOSFET and provide maximum load to the system. And we will actually integrate incremental conductance method in this MPPT. So this method will maintain maximum output from PV cell irrespective of external factors. So this is the flowchart of the incremental conductance method. So from this flowchart, as you can see that there is a maximum power point available. I mean, when di divided by dv equal to minus I by v, then the PV cell will be in the maximum power point system. So when the voltage will deviate from the right hand side or in the left hand side of the maximum power point, the incremental conductance method will act accordingly and put the level of voltage and current always to this maximum power point. So when di by dv greater than I by v, So it is on the left hand side. So it will increase the duty cycle and put the point in this maximum power point. Or when di by dv less than I by v, so the duty cycle will be reduced and the voltage will shift it to again to this maximum power point. So by integrating this method, the PV cell can maintain maximum power output. So we have designed this boost converter circuit in MATLAB Simulink. So as you can see that this is the PV cell and the solar irradiation and temperature has been input in here, and this is the MOSFET switch, and this is the battery storage system. And in the duty ratio block, we have actually integrated the IO conductance method. So based on the mean temperature and the variation of solar irradiance, the voltage of the cell will be deviated. So when the voltage and current of the cell will be deviated, the duty ratio will operate and it will control the output voltage and current to the required level so that the battery storage system can operate at the maximum efficiency regardless of this irradiance and output temperature. So this is the effectiveness of the MPPT charge controller. As you can see that, so in the first figure, in the A figure, when the solar irradiation is 1000 watt per meter square, so it maintains 2000 watt power output constantly. And when the solar radiation reduces, so the output power has reduced as well. So as you can see that there is a small deviation at the beginning, but after that it constantly maintaining 1000 output power. So we can use this MPP charge controller, and if there is any variation of the voltage or the temperature or the solar irradiation, the PV cell will maintain constant power output at every second. So now we will talk about the control system of the wind turbine. So as per this table, you can see that the scenario 1 gives us the most feasible LCOE when the penetration of the wind turbine is 30% and the penetration of the PV cell is 70%. But if you increase the penetration of the wind turbine and decrease the penetration of a PV cell, so the LCOE continuously increasing. So we have to maintain the penetration of the system at the desired level so that the LCOE cost is at the minimum level. So we need to implement scenario 1 in the control system so that the wind turbine generation do not exceed 30% of the total generation. And when the generation of the wind turbine goes beyond 30%, then by pitch control mechanism of the control system, the wind turbine will reduce the generation down to 30% again. And the rest of the generation will come from the PV cell. So in order to achieve the desired penetration of the wind turbine, a PI controller is developed to calculate the output percentage of both systems. So depending upon the percentage of both systems, this PI controller will act accordingly. So this figure shows that when the penetration of the wind turbine goes beyond 30%, the control system will start doing responding, and the output percentage of the wind turbine and again goes down to 30% within 1 second. So the controller has less than 5% overshoot and is accurately tracking down the penetration of the wind turbine. But in case of unavailability of the solar resources, then the percentage may vary, and then the control system will allow the wind turbine to operate more than 30% level. So now we are going to the financial analysis in here. So we will do the financial analysis as per the rate of investment percentage. So the higher the rate of the investment percentage, the project is more feasible. So the rate of ROI is actually based on this formula. So final value of investment minus initial value of investment divided by the total investment cost. So by getting these figures, we will calculate the percentage of ROI. So we have calculated the total investment cost in here. So you can see that the initial investment cost was 17,220 US dollar. The final, which includes the weighing cost, uh, gives us 25,709 US dollar. So based on this figure, we will calculate the off-grid ROI. So the off-grid ROI comes as 33.01%. But as for on-grid ROI, the ROI percent increases to about 10%. So it is now 43.19%. The reason is why, because in the on-grid system, the power is actually available from the grid. So instead of setting up an bulk size renewable system, we can buy a small size renewable system and can get the remaining power from the grid. So it gives us higher ROI and less NPC and less LCOE as well. So this ROI calculation proves that the on-grid energy system, on-grid hybrid energy system is financially feasible than the off-grid ROI system. But it again depends upon the particular location of the project, because if the project is location from far away from the city, or the transmission or distribution line will not be able to be set up, then the customer have to go for off-grid ROI. But if there is any possibility to establish a grid infrastructure, then the on-grid system will be far more feasible than the off-grid system. So in the conclusion, so we have conducted a techno-economic analysis of the hybrid renewable power system in Jharkhand in India. So the reason is why we have considered hybrid energy system, because the single renewable energy system might result in capacity shortage or produce more power than the actual demand. And by choosing the renewable power system as a hybrid basis, we also reduce the size of the battery storage system as well. And we have make a comparison between the on-grid and off-grid hybrid systems, and as you can see that the on-grid system gives a better financial feasibility than the off-grid system. And we get the most optimum results from the HomePro software when the penetration of the wind turbine set at 30% and the penetration of the PV cell set at 70%. To accurately control this penetration, a PI controller is developed and it accurately maintains the penetration percentage to get the maximum power output from the whole system. And we also developed an MPP charge controller with an integration of IC algorithm, because as we are getting more power from the PV cells, so it is important to ensure that the PV cell provides the maximum power output all the time. And last of all, proper financial support from the investors and the government will help to electrify more villages in remote community. And also the most important thing is that the grid operators will be able to reduce their transmission and distribution costs.